everyone, let's talk about extrema. So extrema is a catch-all word for any and all minimums and maximums. A lot of times we refer to these minimums and maximums as turning points. So there are two different types of extrema. There are absolute or global extrema, which means that is the maximum or the minimum over the entire graph. Good deal. Now, relative or local minima and maximum are going to be minimums and maximums just in their little neighborhood of the graph. So let me show you what I mean. This point, actually, let me do that in a different color. This point is the highest point over the entire graph, right? That is an absolute maximum. This is a maximum, but only in his little area, right? Because we already decided that that other guy was my absolute maximum. So this is a relative maximum. The same thing is going to happen over here. He's the maximum in his little area, but he's not maximum overall, so that means that he's a relative maximum. Now let's look at these minimums. Right here, I have more stuff underneath the graph in this area down here that is less than that guy, right? So he's not the most minimum of my graph. That's going to be a relative minimum. Now we've got this point right here. Now, once again, we still have values. See, it's going down right there and right there. We're still going to have y values that are less than that point right there. So that is still a relative minimum. Okay, now this is something that kids get really confused about. Positive infinity and negative infinity are never, ever, ever absolute minimum or absolute maximums. So think of minimums and maximums as values that that function can reach. So let's see, 1, 2, 3. The highest value that this function can reach is 3, right? But if those arrows keep going down and down and down and down, well, my y value can never actually reach negative infinity, right? It's not a number, it's not an actual number, it's just an idea. So positive infinity and negative infinity are never absolute minimums and maximums. So this graph right here does not have an absolute minimum. Cool. All right. So let's go ahead and look at an example. We're going to find and classify all the extrema of this function right here, the x minus 1 times the square root of x. So go ahead and graph it inside of Desmos. I've been hearing rumblings of ACT letting you use Desmos and a few other standardized testing. So we'll use Desmos for right now. So one of the reasons why we love Desmos is that it will tell me all of these points pretty easily, right? So I got those two. Those are my two extrema. This other point right here, he's there because he's my x-intercept, but he doesn't matter to us right now. So we've got this 0, 0 right here, right? He's the biggest value in his little area, but he isn't the biggest value overall. So 0, 0 is going to be a relative maximum. So we're going to go back over here. and we had a relative maximum at the point 0, 0. Then we have another point right here, this guy. He is the lowest over the entire graph. So since he's the lowest over the entire graph, that makes him an absolute minimum. So we have an absolute minimum at, what was it, 1/3, negative 0.385. Good deal. Now we're going to find and classify in x cubed minus 3x. So let's look at that graph. All right. So here we have a maximum up here at this point at negative 1, 2. And then we have a minimum right here at 1, negative 2. So let's talk about negative 1, 2 first. He's the highest point in his little area, right? But he's not the highest point overall. So that means that he's a relative maximum. Whoopsies. So we have a relative maximum at negative 1, 3. I'm sorry, 2. Negative 1, 2. My bad. Good deal. And then we have this point that is the lowest in its little area, but not overall. So he is a relative minimum at 1, negative 2. Go ahead and find the extrema on these last two, please. All right, so on that first graph, let me change this real quick. All right. So we had a relative minimum here at negative 0.0, I'm sorry, at negative 0.906, negative 0.045. We had a relative maximum at 0, 1, and then we have an absolute minimum here at 1.656 and negative 4.248. Good deal. Now on that second one, it's a little bit different. Now our absolute maximum up here at this point is going to be negative 1, 3, which I think we're cool with. But then we have these two values down here that have the same y value, right? So actually both of these are going to be absolute minimums since they both have the same y value down there. So we're going to have two different absolute minimums. So those are what my relative maximums and absolute minimums and absolute maxes and minimums look like. Okay, see you guys later.